I am Dr. Alaku Parvati, Associate Professor of Physics. I am going to discuss about construction and working of Michelson Interferometer. First, now let us discuss the principle of Michelson Interferometer. Michelson Interferometer works on the principle that two interfering beams are formed by a amplitude of division method. These two beams will be obtained from an extender source, and it will be divided into two parts by partial reflection and partial refraction. These two beams will be reflected from the plane mirrors, and they are brought together and interference pattern will be formed. Next we will see the construction of a Michelson interferometer. It has a extender source and two mirrors. They are front silvered and they are placed on an arms, and they are perpendicular to these two arms are perpendicular to each other, and we have two glass plates G1 and G2, and G1 is called as a beam splitter and G2 is called as a compensating plate. G1 will be back silvered and G2 will have the same thickness as G1, and telescope T is a telescope. Now next we will see the working of a Michelson interferometer. Light from a source falls on a lens, and parallel beam of light will be formed. Then it falls on a glass plate G1 that will be back silvered. So part of the ray will be reflected along AC and part will be reflected along AB. The reflected beam then falls on a plane mirror M1, and the transmitted beam falls on the mirror M2. The reflected beam will be again travels along the same path and reaches the telescope. The transmitted beam meets the mirror M2 and again reflected along the same path. These two beams will be interfering and we are getting a interference pattern on a telescope. Since these two beams are derived from a same source, they are coherent in nature. Now the beam which passes through G1 crosses the plate 3 times, whereas a beam passes through transmitted beam will be passes through G1 only one time. So in order to compensate the optical path travelled, we have a compensating plate. The compensating plate have a same thickness as that of a G1. Both plates are kept at an angle of 45 degree to each other. Now let us see the types of fringes formed. Now we can form a circular fringes and straight line fringes. To form a circular fringes, the two mirrors should be exactly perpendicular to each other. Here the mirror M2 is fixed and M1 will be moved. So the virtual image of M2 will be formed above M1 such that M1 and M2 dash form as a parallel thin air film. So the thickness of the air film M1 can be varied such that the beams fall on this air film, interfere, and we are getting a circular pattern. To have a circular pattern, bright fringe, the condition will be 2nt cos r is equal to m lambda, and to have a dark fringe, the condition will be 2nt cos r is equal to 2m minus 1 into lambda by 2. Here at a constant r, the thickness T will be constant and n will be an integer. Now to have a interference pattern at a telescope, now the eye or telescope will be makes an angle r with a normal to m1. So here to have a circular fringe, the telescope should be focused at infinity, or our eye should be focused at infinity. Now if the mirror is moved through a distance of lambda by 4, the central fringe, if it is dark, means The path difference introduced between the two beams will be lambda by 2. Now the dark fringe will be shifted to a bright fringe. Again, if the mirror will be again moved through a distance of lambda by 4, the path difference will be lambda by 2. Now the bright fringe will be appear. So we can simultaneously adjust bright or dark fringe by moving a distance of a mirror m1 through a distance of lambda by 4. These fringes are also called as a Heidinger's fringes. The same thing will be explained using that figure also. Here m1 and m2 dash will be parallel to each other, and our eye will be focused such that we are getting an eye, or the telescope will be focused at infinity, and we are getting a circular fringes of equal intensity. To get a straight line fringes, now the two mirrors should be exactly intersect, m1 and m2 dash intersect, and we are getting a straight line fringes. Suppose if m1 and m2 dash are not intersecting, means the wedge shaped air film will be formed, and as the thickness of the air film increases towards right or left, we are getting a curved fringes. The curved fringes may be convex or concave in nature. Instead of a monochromatic source, if we are using a white light source, means the center will be a dark fringe, and other surrounding a dark fringe we are getting a colored fringes. This white light will be used such that when the path difference is very small, and also in order to locate a zero path difference, we can use a white light fringes. This Michelson interferometer can be used to determine the wavelength of the light or difference between a wavelength of a light. Thank you.